ShopSafe is an innovative solution to make grocery shopping more convenient and safe. As all of us know, new complications have arrived due to COVID-19. One of the biggest changes is how we conduct errands, such as grocery shopping. Whenever we go to the nearest store, we see lines like these stretching across the parking lot. These lines turn what would be a quick trip to the store into a long wait. For a lot of us, grocery shopping is one of the few occasions where we go near random people. These few occasions thus are the few chances where COVID-19 could affect us, due to the abundance of people gathered at these stores. ShopSafe aims to eliminate that chance through a simple yet elegant solution. Our product has two parts, the hardware explained here.
So here we have an Arduino connected to a small servo which is moving this piece of cardboard, which is a representation of a door. So when it detects a face mask is there, it will open the door, and after a couple of seconds it shall close.
Okay, so this is the hardware demonstration for our smart door access using mask detection. So here we are simulating a door using a servo motor and an Arduino, and we are going to use a webcam to detect whether our user who's going to attempt to access the door is wearing a mask or not. All right, let's go.
The webcam is right now initiating. It takes a while for it to
Be heavy on the TensorFlow. Okay, so now it detects that he did not wear a mask. So it says no mask detected. I'm gonna get out of the... And now the door is open because it found a mask.
The webcam is connected to the platform that uses a machine learning algorithm that uses boundaries that demarcates whether a user has entered or exited the store. The population and entrance/exit rate is then sent to a backend which our software uses to calculate the queue times, which will be explained later. For the software, we used Flutter, Google Maps API, TensorFlow, Keras, OpenCV, and Python. Flutter was used to build the front end, which utilized the Google Maps API for the search stores function. We created the machine learning algorithm using TensorFlow and Keras. With OpenCV, we captured a video stream from a webcam and processed every frame, then passed each frame into a neural network that was trained on a dataset of face images, both with and without masks. This was a hard cascade type of classification which made a detection of a face, outlined the mouth region of the face, and tried to detect a mask object. The algorithm ran through each frame, and if it detected a mask, it would send a signal via a serial port to the hardware. Our system used a Python library called PySerial to communicate between the software and hardware. The simplistic interface provides a great user experience for the customer. Users can choose a quick queue, which instantly queues you up with your most frequently visited stores, or they can press the search button on the screen. This button takes you to the map, implemented through the Google Maps API. Here, there are markers which show you where your nearest stores are, depending on your location. There are also descriptions at the bottom that tell you the details of the store and the estimated wait time for each store, allowing users to know the scope of the trip. When you join the queue bar shows up, and there will be a timer that shows you how much you need to wait. When the timer nears 0, it tells you to start walking toward the entrance of the store, allowing you to stay in the car and minimizing contact until you actually need to go in. The user is then prompted with an enter the store button, and they click confirm or cancel, which indicates whether the user is going to go or cancel their spot so others can move up in the queue. We believe that this product has tremendous startup potential because of how simple and ingenious it is, as well as it can be used with any store around the world. Almost every store today has lines that you need to wait in before entering. Our product can be thought of as making reservations at a restaurant, which is done frequently. According to OpenTable, over 2 billion reservations are made each year. Now imagine how many people would use ShopSafe today. With our app, you have no need to go to the store and line up. You can merely join the queue and then go to the store when the waiting time nears 0, cutting the time of contact with people dramatically. This will inevitably lead to slower spread of COVID-19. Also, the hardware component of our product is very cheap. As seen in the demo, our algorithm detects masks on people's faces to allow entry and increments the population within a store using image detection on boundary lines. Our high success rate in training our neural network ensures ShopSafe can work efficiently in the real world. This practical application of machine learning can be used to solve a current issue in every city. I actually couldn't believe no one had thought of this idea yet. It seems like common sense for a queue to be employed in stores today. It just shows how viable our product really is. Thank you for watching our video.